All right. So, okay, I hope you are ready for our next talk. This next talk will be by Clara Higuera. She's a data scientist expert at BBVA Data Analytics. She's going to be talking about NLP and a lot of data science stuff. So get ready and comfortable, and the stage is all yours, Clara.
Hello, everyone. I'm going to share now. Can you see my screen?
Yes. You want to
Perfect.
present? Yeah.
Yeah. Um, Great. Hello. Thank you very much for this introduction. And yes, I am Clara Higuera. I am a data scientist at BBVA Data Analytics. And today I would like to tell you about my NLP adventures in this financial organization. So usually when you study data science or analytics, you focus a lot in the step of training the model. However, the reality in industry in this reality, there are steps that are before and others that come after that step. For example, if you want your model to live somewhere in the infrastructure of an organization, you need to put that model into production. In this presentation, I'm going to walk you through a real use case that we have worked in my team, from the business need to the model in production. So what do we do? In BBVA, many customers and more each day are using the app to communicate with their financial advisor. So in my team, we work in building AI products that help these financial advisors to communicate with the clients and assist their requests. Because this communication is through text, we use natural language processing techniques to assist them. And one of our goals, among others, is to help them decrease the average response time per interactions with the clients. So what sort of things are we doing or we have done? So we have worked in a conversations classification. We are working also in routing, like some conversation need to be handled by certain types of roles and others by other types of roles. We have also another model that is already running live, which we call close conversations. So when the financial manager doesn't need to respond again to the client or the conversation is finished, that conversation is archived automatically. We are doing also some research in automatic response, not so much in the field of chatbots, but to be able to suggest financial advisors with responses that may help them to answer faster. So when you are working in an NLP product or basically in any machine learning product, from the business need to the phase where you put the model into production, there are many obstacles that you need to overcome, and as much as I can summarize these steps, there are always surprises. That's why I'm making the analogy with a video game. So who's playing in this? Here I introduce you to my team, who is led by Angela Gonzalo, who is the business translator, and she knows all about the business and the ecosystem of the financial advisors. And you can see, we are a very multidisciplinary team. We are data engineers, data scientists, data architects. Also, we work in Agile, so we have a Scrum masters that help us do the work. So going to the topic of today. So when we're working in a real use case, there are different stages, and here we're going to talk about a conversations classifier that we built. So here you can see that these different stages are the problem definition. What do we want to do? What data are available? So what can we do? Then there is a step called data ingestion and preprocessing, because we need to prepare our data for to be ready for our models to be ingested. Then it comes the famous phase of model training and validation, and then productionization of the model. So I'm going to go step by step through these different stages. So what is the task that we want to do? The financial advisors, every time that they interact with a client, they have a conversation through text, and they need to label that conversation with sort of a subject, which we call product and operation. For example, if a client wants to cancel their credit card after the request has been handled, then the financial advisor needs to tag that conversation with the labels card and cancellation, and the same with other types of financial products. So as you can see, this is not a very enjoyable task. So we thought of building a classifier that helps the advisor or the assistant to classify easily, and not having to scroll down and search the categories. So what data do we have available? In this case, we have conversations between the client and the advisors, and we have more than, well, around 32 products approximately. And as you can see, we have conversations about different products, and we don't have the same volume of conversations about all the products. In terms of operations, we have more than 120. And what we used for our use case is our 200,000 conversations that were labeled by the call center. So how do we prepare the data? Now it comes the stage of data ingestion and preprocessing. So in this case, the messages, the conversations, the information about the assistant manager, even the labels of the products and the operations come from different tables that need to be joined and merged. And also, because we're dealing with text, there are also sensitive information that we need to anonymize, for example, credit card numbers or telephones. So we do that, all that pre-processing and arrangement of the data with the construction of a pipeline. And this pipeline is one of the very first steps that needs to be done. So after we run it, we can have a neat and nice data set that we can use for starting analyzing. So now it comes the time of training the model and validate it. And usually, well, if you know a little bit about machine learning, you probably already have guessed which kind of problem we're facing. And it is a classification problem, which can be solved with supervised learning methods. And usually these methods classify samples of elements or individuals as well, to which we know which class they belong to. How do we represent these samples? Yeah, so usually they are represented by numerical values, and depending on the values of those elements, then the algorithm will be able to discriminate between the elements into the different known classes. However, when we are dealing with text, we need to convert that text into a numerical representation. And there are two techniques that we can use. One that is more traditional, it's called bag of words. And what it does is it uses the frequency of the words in each conversation or in each sentence. And then we can have a vector of words with the frequency, and that would represent or be informative of that conversation. There is another type called of technique, which is very similar, called TF-IDF, which penalizes the words that tend to appear many times in the different conversations, which is usually a little bit better in this type of techniques. And then we have word embeddings, which are models that convert words into vectors. But these are models that have the peculiarity that convert the words into vectors that those words that share semantic context, their vectors will also have a similarity, or they will be closer in their mathematical space. So this is an advantage against a bag of words, because it keeps that semantic meaning. And this is more used in deep learning methods or algorithms. So once we have translated our text into mathematical representation, we have different algorithms, and in our case we tested 3 of them: random forest, naive Bayes, and support vector machine. But how can we know which one is better? We need a way to evaluate it and validate the models. And here I'm going to explain the 3 different ways that we have used for validating our model in this use case. So the traditional one, that is the one that should always be done, is splitting the data set into training set and test set. So you train the model with the training set, and then you test it in the test set, which contains samples that the algorithm has never seen in the training phase. So this way we can compute the precision, recall, or whatever is needed. And in this case, I've displayed here an example, which the overall precision is 83, but we can also see the different precisions per class. However, we weren't super satisfied with only this type of validation, because our model is going to be live, and the financial advisors will have to handle a lot of conversations, and this might change through time. So we weren't sure with this method if the model was going to be stable through time. So the second thing that we did, and this is something that we came up with for this special case, was okay, so we can train our models with the historical data, and then, for example, from 2019 we take the months from January to April, and we see we test the results in May, and then we do another check that is okay, we can use January to May, and then we test with June, and the same with July. This way we have like a threefold validation, which contains and captures also the temporal movement of the data, or the variation of the data. And then when we did this, we realized that the results weren't very different between months, so we could state that our model was somehow stable through time. And then the last type of validation that we did was a manual validation, which is very common in natural language processing problems. In our case, we had data that had been labeled by the call center. So if you can see here in the graph on the right that we mostly have data from products like cards, accounts, mortgages, transfers, etc. However, we have very little conversations about these other types of products, which are the type of products that handle the BBVA financial advisors, who are the people that are going to have our model launched in their tool or in their application. So here we can't estimate, or we can't know how the model is going to perform for those users. So in this case, what we did was we got together in the team, and we decided to do manual annotation of a specific of some conversations. So this was a bit tedious process, but I'm going to explain it the important things. So first we took a sample of 120 conversations, and we were 12 people. So we built a Jupyter notebook, and there we could annotate different conversations and say, okay, this conversation is about cars, this is about insurance, etc. However, we aren't financial advisors, so we weren't sure whether we were doing that correctly. So what we did was to use one metric called Cohen Kappa, which gives you a score of how an agreement score between pairs of annotators, and then it can tell you how much you agree on the same conversations. So a good value of this metric is usually around 0.6, as is stated here. So what happened? After the first round, we computed this metric, and we saw that we got an average of 0.45, which means that, well, many things, but to start with, that it's not so easy to label. So many of us were thinking about different things. There were a lot of mismatch. So what we did was to revise the annotation guidelines, we revised the description of the products, etc., and we did that for 3 times. So when we were sure that we were more aligned, as you can see in the third round, we reached a level of 0.55, and then we annotated 2,400 conversations between 12 people. And here you can see that for at least 16 products, we got a good alignment. So this gave us confidence that that data set was going to be somehow, we could trust this data set. So with these 3 types of validation, we then ran different algorithms with different hyperparameters, and then support vector machine was the one that gave us better results. So it was the winner. And the last stage is putting the model into production. And I won't go very deep into this, but this is something that data scientists sometimes forget to talk about, and in the end is something that affects our work, because the decisions that we make while we train the model will affect the architecture, and the architecture will affect also our models. So here you can see this is the final architecture solution, and here this is the financial manager's interface that receives a question from a customer. Then in this interface, he or she has a button to classify. So this will send a request to our model with the conversation with the client, with the text, and then our model will give back a prediction, in this case, cards and cancellation. This seems very simple here, but in reality is something more like this, which is already simple, but there are more components. And here we have some characters which represent the different teams that are involved in making this work. So this team will work on making sure that our model doesn't do too many requests and break something in the bank. This, for example, are a team that work on making sure that the API we use to serve the result or the predictions doesn't interfere with the security of the bank, because we are handling very sensitive data. And this is us. And then there is the people that work on the financial manager's interface. And the message here is that all of us need to have good communication skills to be able to step on the shoes of others and be able to communicate and make all this work well. So it's not only about the model. And I would like to finalize with a message, which is no matter in which stage you are of this process, that you might have to go back as in a video game to the early previous stages. For example, you can be in the productionizing the model and you realize that the model is too big or you cannot deploy a super mega deep learning model. So you need to go back and make your model a bit more simple or basic and do some like reach a consent threshold of accuracy, for example, or maybe you need a variable, a new variable, and you need to go back to the pipeline and ingest that data, or even you might have to go back to the problem definition and say, well, we're classifying products, but we have complaints, and the algorithm is categorizing it as products. For example, a complaint about cards, the model will say cards. This is something that happened yesterday, for example. So maybe we need to take that into account and build another model for that. So that's all, and I hope you found it interesting. And I don't know if there are any questions.
Thank you, Carolina. You have few questions. And also people were mentioning that the explanation was very clear and very precise. And the first time they're understanding NLP. So yeah, thank you. And you have a couple of questions there. You see them on the chat?
No, I can only see
on the chat scenario, like stage.
Wait. Yeah.
Or I can read them for you. Look, so the first one is, what stages have required more time and effort than expected?
A good question. Let me see. Oh, I'm not sharing any. Oh, yes. Definitely the data ingestion and pre-processing. That gives a lot of headache. Yes, because we need to pre-process the data, and also this is one of the stages that you need to go back many times because you need the data or the conversations in a different format, or you want to arrange them differently. And especially we do a lot of heavy pre-processing, identifying the language, so we can have a column that says this is in English, this is in Spanish, so we don't have to do that while we are analyzing. So yeah, definitely. And there is a lot of back and forth between the training and the productionization of the model. Yeah, once we had to, as I said, the model was too big and it couldn't be deployed, so we had to change it to a less precise one, which was smaller.
You have one more question, and that's the last one we're gonna take. So, yeah, thanks, Clara. Wonderful presentation. You can, if you go, yeah, there you go. Like Idoia Martí.
Yes. How do you normally manage to work with text coming from humans containing misspelling, mistakes, informal words, etc.? And also, what about using different language in the same conversations? For instance, using English words in Spanish conversation. Yes. Yes, the text coming from humans is messy, and we have done some, implemented some functions to like correct some parts or some words, but usually because we have a lot of data, we ingest everything as it comes. And then also we are a bit lucky because our conversations are quite formal because they are always about some type of financial product. But yes, so we don't do much about it. We should do more. But and also about different languages. That is a very, very good question. We have done an innovation project which uses BERT, which is a deep learning model that is able to handle text in different languages, and we actually trained it to classify this same use case with text in Catalan and in Spanish, and it wasn't working bad. It's still under analysis, but it's very good because in that case we don't have to deploy 2 models. We could deploy only 1 model, which will spare us a lot of infrastructure thinking and resources.
Amazing. I think you have more questions, but we are running out of time. I'm going to encourage Laura Perea, which I know her very well, to send you a private message, Clara, so maybe you can answer her, since we have the second speaker waiting for us. So thank you, Clara, very much for that great presentation. I hope you enjoyed, and we could feel that you love NLP and everything.
Yeah.
So,
thank you.
Thank you.